अच्छा, बस बोल्ट्जमान डिस्ट्रीब्यूशन उसका तो you probably already know what the Boltzmann distribution is, right? तो वो हमने किया था. uh, Together we studied कि भी if you decrease temperature तो higher energy you have fewer particles and at low energy you have more particles. ठीक है, so the curve would look like the blue curve. Or higher temperature पे you're going to have more particles at higher energy and less particles at lower energy. So the curve would shift to the right. ठीक है. फिर ये बोल्ट्जमान डिस्ट्रीब्यूशन आफ्टर द बोल्ट्जमान डिस्ट्रीब्यूशन. ठीक है, ये इम्पोर्टेंट था कि this is where we started A levels के how is the how is the rate of reaction measured. ठीक है, बाबा आपका माइक ऑन है. अच्छा, how is the rate of reaction measured? तो ये हमने लास्ट क्लास में डिस्कस किया था कि rate is what? It's the speed of a reaction. It's the change that happens in a certain amount of time. ठीक है, तो वो 100 मीटर रेस की एग्जांपल ली थी कि how do you measure speed? कि it's how much distance changes with respect to time. So this change could be anything. For a reaction, it's not distance. For a reaction, it could be a color change, how quickly a color is changing, how quickly the concentration is changing, how quickly the volume of gas is changing, yeah, how quickly is the mass changing, the okay, if something is dissolving, so how quickly is that happening? So this change could be anything. ठीक है, तो ये वाला reaction है, for example, तो उसमें a lot of things could be changing. The mass of Mg would be changing. So rate of reaction could be the mass of Mg per unit time, right? Or क्या हो सकता है? It's the concentration of HCl would be changing. So it could be the change in concentration of H divided by time. It could be the volume of H2 gas that could be changing. So it's the volume of H2 gas with respect to time. So rate is any change with respect to time. Or हमने उसमें कहा था some changes are increasing, some changes are decreasing, which means कि volume of H2 gas जो है ना, that's an increasing change. It goes up and then flattens out. That means the reaction has stopped. Or it could be a decreasing change. It's the mass of Mg जो है, that is decreasing. और फिर एक point के बाद it's going to stop decreasing, right? So, लेकिन whether it's an increasing change or a decreasing change, the steepness of the graph or the gradient of the graph, that is the rate at that particular time. So rate की direction doesn't matter whether it's a positive gradient or whether it's a negative gradient. What matters is the gradient itself, the steepness, right? So rate is basically gradient of the change versus time graph. और फिर I told you कि sign जो है ना, that doesn't matter. Steepness matters. And so steeper means, ठीक है, the steeper it is, the faster the reaction. ठीक है. तो और फिर last time we discussed one thing कि this is one way of measuring the rate of reaction. लेकिन this is not a good way of measuring the rate of reaction. क्यों? क्योंकि it's plotting graphs takes a very long time. ठीक है, जैसा वो 100 मीटर रेस है ना, 100 meter sprint है, there's a runner running 100 meters. No one actually measures maybe 1 second per distance कितना है, 2 seconds per distance क्या है, 3 seconds per distance क्या है. I mean, they don't do that. They don't plot a graph. So what instead is done is they keep the change constant. They don't care about the change. They just fix the change. And they just focus on the time. And that will give you the rate of the reaction. Rate of reaction is basically 1 over time. But you can ignore the change that is happening if you can only ignore it if the change is constant. In the 100 meter race, you know everyone is running 100 meters. So that's a constant change. So this wo jo numerator that kind of becomes irrelevant. Okay, if you do it for every runner the distance would be 100 meters, right? तो फायदा क्या है वो calculation में? I mean, it's just something that's going to be very common. So time for every runner would be changing. So the rate would be 1 over time, right? So one method when you want to focus on the overall, especially in cases where you don't care what is the rate at every random time, you're only interested in the overall speed. तो rate is what? It's 1 over time. और लेकिन उसके लिए शर्त ये है कि change is constant. यानी if there's a color change, for every reaction it should be the same color change. For some reactions it would take a longer time. For other reactions it's going to take a smaller time. So you will figure out what the rate of reaction is. Uh, for example, अगर वो H2 gas वाली बात है ना, if you say कि every time you want 10 cm cube of H2 gas to be measured, so sometimes it's going to take long time and sometimes it's going to take a quicker time. Lekin time enough is sufficient to figure out what the rate of reaction is. So without plotting a graph, this is how you actually measure the rate of reaction. ठीक है? ये clear है सारों को? Is this clear? Baba, Omar, Binil, Nala, is this clear?
Yes.
Yes, sir.
तो अच्छा अब उस पे आगे थे कि I told you officially rate is what? It's like in I mean it could be any change. Like in most of the questions that you're going to solve, it's a change in concentration with respect to time. Okay, I mean most of the questions you're going to deal with, rate is change in concentration with respect to time. Or I just told you a few things. Those few things were okay, you've got a reaction, A reacting with B and producing C. So when you define rate as the change in concentration with respect to time, so उसमें one issue is that the change in concentration of B is going to be 3 times the change in concentration of A. But if every 1 second, 1 mole of A gets used up, then in that same second, 3 moles of B are going to get used up. And in that 1 second, 2 moles of C are going to be produced. So change in concentration of B because there are more particles involved, its change would be a lot higher compared to A, right? So since it is the same reaction, what needs to happen is that you need to normalize this. You might measure rate with respect to the change in concentration of A with respect to time, right? Or rate could be defined as the change in concentration of B with respect to time, or it could be change in concentration of C with respect to time. Uh, but since all three values will actually come out to be different. So one way that all rates come out to be exactly the same because it's the same reaction. Well, it's the same exact reaction. What needs to be done is some normalization has to be done. So if you're measuring rate with respect to B, you're going to divide the rate by D. ताकि वो normalize हो जाए, like, because otherwise it's going to come out to be 3 times more. If you're measuring rate with respect to the concentration of C, you're going to divide it by 2, coefficient 2, so that you normalize it. Otherwise, the rate of with respect to C would be 2 times the rate with respect to A. ठीक है, A के use up हुआ है तो उधर twice as many molecules of C are going to be produced. So the change over here is going to be a lot faster. So since it's the same exact reaction, you can pick any reactant or product and measure the change in concentration with respect to time. Lekin you got to normalize it. You have to divide by the coefficient to normalize the rate value. ठीक है? ये भी clear है बात? हाला clear है?
जी
बाबा?
सर, क्लियर है।
ठीक है. अच्छा, अब आगे we're gonna jump to, so we just figured out how to measure the rate of reaction. What we're now going to do is we're going to talk about order of reaction. Basically इस पूरे chapter में ना order के ऊपर chapter है, ठीक है? So we're going to talk about वो जो पिछला सारा था ना वो तो फिर it's kind of linked to IGCSE A levels. So order of reaction. What is order of reaction? So order of reaction is कि um, for example, I've got a reaction. A plus B are reacting and they are producing C. Okay, so there's this random reaction that's happening. Now, normally the rate of the reaction depends on the concentration of A and the concentration of B. Okay, normally that is, but A की concentration, if you increase the concentration of A, you're going to have more collisions between A and B and you'll get a faster reaction. You increase the concentration of B again, you're going to have more collisions with A and you're pretty much going to have a faster reaction. C के ऊपर ना normally the rate of the reaction does not depend on the product. क्योंकि product doesn't really, but the product जो मर्जी collide कर ले, I mean it's not really important. So one relationship that you can describe is, and that is known as the rate equation. You can say that the rate depends on the concentration of A, and it also depends on the concentration of B. ठीक है? ये clear है यहाँ तक सारों को? उम्र clear है? मेरा वाला clear है?
Yes.
Yes, sir.
तो रेट ए और बी में डिपेंड कर रहा है ना, ए ज्यादा करोगे तो रेट ज्यादा हो जाएगा, बी ज्यादा करोगे रेट ज्यादा हो जाएगा, ठीक है? So it depends on A and B. So this is kind of your rate equation. But there's a thing called order of reaction, and that is that rate would depend on the concentration of A, but there's going to be a power, an exponent, which is small a in this case. And rate would depend on the concentration of B, but it's also going to have a power on it, ठीक है? इसको क्या हुआ? Target. अच्छा, it's also going to have a small power on it. Yeah, that is the exponent. Oh, the small a and small b, those are basically those are referred to as the order of reaction. Okay. And if you want to get rid of the proportionality sign, so you're going to add a rate constant. But normally proportionality, you get rid of it by adding this. So it's a, and the power is small a, and similarly it depends on b, and the power is small b. Okay. So right now it says small a, small b. I'm going to talk about it. So order is basically the small a and small b. It is the exponent of the concentration of a reactant use the exact definition. It's the exponent of the concentration of a reactant in a rate equation. It basically describes how the rate is dependent on the concentration of A. That is determined by the small a. अब मैं वो बारी बारी बताता हूँ कि how would that be? How would that affect? Okay, what is the order? So orders are normally whole numbers. So we will talk about order 1 first. Okay, let's say order is 1. So if I say rate is dependent on the concentration of A, मैं थोड़ा A को isolate कर लिया, ठीक है? Rate is dependent on concentration of A and small a, ठीक है? And I'm saying order is 1. So basically what I'm saying is that A is equal to 1, right? So that means my rate is dependent on the concentration of A and the power is 1. As a simple words, if the power is 1, that doesn't really mean anything. It just means that rate is directly proportional to the concentration of A. So when the power is 1, it describes the relationship. The order 1 का क्या मतलब? It means the rate is dependent on the concentration of A and it is directly proportional. Direct proportionality, right? And so what that means is, if concentration of A is doubled, so collisions double हो जाएंगी and the rate of reaction would also. The rate of reaction would also double. ठीक है, तो is this clear what order 1 is? ये clear है सारों को?
Yes.
Baba hala is ऊपर clear है?
Yes, sir.
तो बस A जो है ना that's the power. अभी हमने we just did order one. And so that just means कि so remember फिर से मैं simplify करूँ कि वो क्या था कि the rate depends on the concentration of the reactants, right? And you can come up with a rate equation, which is that rate is basically dependent on the concentration of A and the concentration of B. ये आ जाता है when you get rid of the proportionality. And this A basically determines के how it's dependent. So we just did order one at the moment. जिसका मतलब directly proportional है. That means ठीक है वो A को double करोगे, A को triple करोगे, the rate of the reaction would also triple. Now, moving on, इसी के I'm going to make graphs for order one. Okay, how would the graph of, I mean, there are a couple of graphs that you would be asked to identify. एक तो बड़ा simple है कि direct proportionality का graph. One of them is, well, you keep on increasing the concentration of A. What happens to the rate of reaction? The rate of the reaction would also increase. Proportionality, proportionally, right? This is this is order one graph. Okay, which is pretty obvious. So there's another graph which is graph को ना थोड़ा सा समझना है. And that graph is कि you've got so let's say you've got a reaction is in progress. Okay, so imagine there's a beaker, and in that beaker there is reactant A. Okay, so you've got all these particles of A. So यहाँ पे ना this graph is on this axis you've got time. And just say imagine you've got, I mean these particles are basically your reactant A. And remember it's an order one graph. So I've got A's concentration, which initially is at this point. So slowly what will happen is, remember, order one ka matlab, if A's concentration decreases over here, yahan pe na if A's concentration starts to decrease, and it will decrease, all reactant concentrations would decrease. ठीक है, यहाँ पे लिख भी देता हूँ. The concentration of A, which is my reactant concentration, decreases with time. So slowly what will happen is, okay, this beaker over here will have lesser and lesser particles of A. तो उससे होगा क्या? If A concentration continues to decrease with time, the reaction will proportionally slow down. So the rate will proportionally slow down. ठीक है, यानी अभी शुरू में A की concentration is let's say 1 mole per dm cube. After some time, the A's concentration will get used up and it will become 0.5 mole per dm cube. So the rate of reaction will become exactly half. So how do you do this? ये कितने boxes है? एक second. तो यहीं पे रखते हैं. So this is how your graph would probably appear. If A's concentration starts to decrease, ये कितना है? It's 5 boxes. Let me. ये पहला हो गया. मैं अब तो shape क्या होगी? अच्छा, इसको half करना थोड़ा मुश्किल हो रहा है. एक second. End कर देते हैं. Correct. So I'm going to start over here. That's the first point. ठीक है, then the shape would be इसका half क्या होगा ये? अच्छा, अब next वाला half 1.5, so somewhere around 0.75. What's the half of that? It's, let's just start with Kinetics. Let's just so 9 plus 3 by x. Acha, so the idea is, now listen carefully. A's concentration is decreasing in the reaction will slow down. So right at the beginning, A's concentration in the beaker is really high, so the reaction is like very fast, it's very steep. And slowly with time, the reaction continues to slow down. The curve becomes less steep and less steep. क्योंकि it's slowing down. A use up होता जा रहा है, A's concentration is decreasing. And वो जितनी कम होगी, the reaction would slow down further. It's going to become a flatter and flatter line. The idea clear है how the graph looks like if it's order 1. And how does the concentration of A with respect to time changes in the reaction. Is this clear?
Yes,
Clear,
sir.
Bhava? Uber, Menal, clear?
Yes.
So start में fastest है क्योंकि A's concentration is like really high at the beginning. Gets used up, becomes slower. Get A continue, मतलब नीचे जाई जा रहा है. A is continuously getting used up and it's becoming, the line becomes flatter and flatter. ठीक है? अच्छा, from this graph, there's a thing which, well, when you plot A's concentration over time in a particular reaction, right? There's a thing called the half-life. And that half-life basically is the time it takes for the concentration to decrease by half. Now, I said this half-life for an order 1 reaction, it kind of remains constant. So ये हो गया एक second. So this half-life remains exactly, फिर यहाँ पे खींचा, this is the next half-life. Then how much time would it take for the concentration to halve? Again, that's this half-life, and so on. Okay. So basically, what is going on is that uh, ये वाला जो part है, that's the first half, 0.5. Then the next one is the half of this half. For the next time, it's 0.25. Okay, it's not further and further. It's half of the previous one, right? So if we basically इसको के values में लिख देते हैं कि if we start with the, so if we start with 1, this is 0.5, then this point over here would be 0.25. The next point would be 0.125 mole per dm cube, like if we start with 1. And every time you'll notice that the half-life is exactly constant. It's T1 up to this point. The next one is T2. The next one is T3. The next one is T4. But every time it takes pretty much the same amount of time. So the rule for a first order reaction is that all half-life is constant. So it always pretty much takes exactly the same amount of time for the concentration to decrease by half. Okay. Even though, but यहाँ से यहाँ the, but it's a smaller distance to cover, right? But because the concentration is lesser, therefore it slows down and the reaction pretty much takes exactly the same time. Okay. So idea clear what half-life is? Is this clear?
Yes, sir.
As I've explained the two things. But when we move to order 0 and order 2 as well. Now remember two important things. The two important things are कि by looking at the graph, you can tell what the order of the reactant is. If you see this graph, you plot the graph, you plot the concentration of A with respect to time, and you see the concentration changing in this way. And then you go and measure the half-life, and it comes out to be constant, right? So that instantly means it's order one. Yeah, but if you plot this graph, which is in the same in several experiments, अच्छा इसके अंदर you do several different experiments. But उसके अंदर तो एक ही experiment था. This was the same experiment, and the concentration was plotted. Over here, it's basically uh, concentration versus rate. ठीक है, इस वाले में concentration versus rate is plotted for several experiments. So this is another way. If you do several experiments, you keep on doubling the concentration and the rate also doubles. That means it's order one as well. Okay, so graphically there are two ways. Yeah, half-life देख लो या वो वाला graph बना लो, ठीक है. And by looking at the shape, it would be evident it's order one. Okay. So next is we're going to move towards order two. Okay, this was order one. या बल्कि order zero पहले कर लेते हैं. That's easy. अच्छा, order is equal to zero. Now order zero means that rate is dependent on the concentration of A, but A has a power of zero. What that actually means is what that means is that rate is not actually dependent on A. What that means is whatever the concentration of A is, anything to the power zero is one, right? So that means no matter whatever concentration of A you take, you will get the same value of rate. Okay, so you keep changing A's concentration, it will have no effect on the rate of reaction. So पहले वाले में directly proportional था. पहले वाले में order one में it was you change concentration of A, the rate changes. Now you keep changing A concentration, and rate remains completely unaffected. Anything to the power zero is just one. So you always get exactly the same value. तो इसका मतलब ये equation लिखना भी ना, it's like a waste of time. I mean, there's no point writing this. I mean, A is not doing anything to the rate of reaction. अच्छा, but anyways, how does the graph look like for a zero order reaction? So if it's zero order, it's going to look something like this. So पहला वाला तो simple है, rate versus A's concentration. So I plot A's concentration. I've got rate over here, and absolutely nothing is going to happen to the rate of reaction. You keep on changing A's concentration, it's pretty much going to remain unaffected, right? ये clear है? हवा
Yes.
हाला मिनल clear है? और अगला जो है ना वो ये कि so the other graph, which is in the same experiment, if I plot A's concentration with respect to time, well, let's go this should be on that side. So with respect to time. So now in this one, the graph was going to be a straight line. What that means is it's not going to slow down. Remember, rate is the gradient, right? So if A's concentration decreases, right, the speed, I mean, it should slow down, but in a zero order reaction, A's concentration has no effect on the rate of reaction, so it doesn't really do anything. Okay. So the gradient or the speed of the reaction it does not change uh, when A gets used up. अच्छा अब ये कि most reactions are not like this. Most reactions are actually like order one. A कम होगा वो slow down हो जाएगा, ठीक है? There'll be fewer collisions. So most reactions they don't follow zero order. I mean there are some reactions that do follow zero order. वो हम बाद में discuss करेंगे क्योंकि कोई फर्क नहीं पड़ता रेट पे. No matter if A gets used up or not. ठीक है? अच्छा अब last one, that's order two. Order two basically means that the rate is overly sensitive to the concentration of A. If you disturb A a little bit, there's going to be a huge change in the rate of reaction. Okay, what power 2 means is, इसका मतलब if you try to double the concentration of if A is doubled, then the rate would be 4 times. Yeah, that's one. You double A and the rate would become 4 times. So it's overly sensitive. A ko chheda, the rate will go out of control. You triple, if A concentration is tripled, square है ना, so the rate would be 9 times. So this relationship between the reactant concentration and the rate of reaction, that just means it's kind of overly sensitive. You touch A's concentration and the rate goes out of control. And the reverse is also true. When it comes to slowing down, if A is halved, then rate would be half का square क्या होता है? That's 1/4. So when it comes to slowing down, the rate would also slow down a lot faster as well. Okay? So is this relationship clear? The order 2 means it's overly sensitive to rate. ये clear है?
Yes.
तो मामा clear है? हाला, is this clear?
Yes, sir.
चलें अब ये कि the last thing is कि order 2 का ना graph, we'll just do the graph for order 2. The first graph is जल्दी से graph बना लेते हैं. So this is A's concentration and this is rate. So it's probably going to go exponentially. I think it's just exponentially it needs. ये ठीक है. So it's just going to go up exponentially. And the other one is कि if I वो दूसरा वाला trick here. So if I have where's other boxes कर लें. So just if I plot A's concentration in an experiment with respect to time. So this is how you get the most. 1, 2, 3, 5, 6, 16. So this is A's initial concentration. And this is the time required for the concentration to decrease by half. So initially it decreases very quickly. लेकिन क्योंकि it's overly sensitive, so if A's concentration decreases, the reaction slows down by twice the amount. So the next half-life is going to be double the previous half-life. So the next half-life would be but it's going to take a bit more time. Next time, it's going to now the concentration has decreased further, and now it's going to slow down by a lot bigger margin. Okay, so it's going to slow down too much. So over 2 boxes, then now it's going to be 4 boxes. So basically, it's slowing down very quickly. Now 4 boxes. Next one, it's going to be 8 boxes. Okay, 4. तो यहाँ पे पहुंच जाएगा. ठीक है. So the point is, the reaction just slows down too much, and as it's slowing down, it just takes a longer and longer time. चलो ठीक है, काफी. So the first half-life, that is this. First half-life होगी. Second half-life takes a longer time. So the half-life doubles. Third time, half होने में it takes an even longer time. So you get the idea that the half-lives are doubling. So you T first half-life, T2, that's the second half-life, T3, that's the open, it just slows down too much. So every half-life, every time it takes twice as much time to for the concentration to decrease by half, it just slows down too much. So every half-life is double the previous half-life. ठीक है. तो ये तीन concepts है, order 1, order 0, order 2. ठीक है. And this is the first way of finding out what is the order of reaction. If you can plot the graph, and you can have a look at the graph. So the half-lives, I mean, you can plot either of the two graphs. The half-lives will give you an idea about what the order of reaction is. अच्छा, इस वाले में ना half-life is not really important, लेकिन because the shape is pretty obvious. इसमें क्या होता है, every time the half-life 0 order में ना half-life becomes half of the previous one. It just अगला half होने में it's just going to take an even smaller time. First half-life, this is the second, this is the third one. लेकिन इसमें the shape is enough. You don't really have to even talk about the half-life. ठीक है. तो चल ठीक है, ये कल कंटिन्यू करते हैं. ठीक है. Okay, everyone. हाफिज.